So what I'm showing you here, it's the latest EM simulator, Momentum GXF. It's a planar electromagnetic simulator, and what you're seeing here is the solution of simulating an LTCC filter. It's a multi-layer, three-dimensional filter, and what we're seeing here is the final solution, and we're looking at the surface current flow across the planar structure as well as through the vias in the vertical structure. And the nice capability here in the Genesys is the ability to look at it in 3D. So you see I can rotate this in 3D, which was not possible before. You can also view the layout in 3D as you are designing it before you do the simulation. And once more, you can also look at the layout with the vertical dimension stretch so that you can check the accuracy of where you place your vias, because especially for multi-layer structures, one wrongly placed vias can destroy the structure and the design. So you want to verify that before you do your simulation. At the same time, we also have the ability to cut through the structure. Let me show you that. This is the cut plane that you can specify in order to traverse through a complicated layout, for example, to make sure that everything is properly set up before you do the simulation and before you send it off to manufacturing. So next, I would like you to look at how we take a PCB, RF PCB prototype that you have designed and move it into actual creation of the hardware. So come over here, I'll show you what we do here in the fastest prototyping from design to manufacturing. So what you see here is a bandpass microwave filter synthesized in Genesys, laid out in Genesys automatically, and then we do the electromagnetic simulation on the layout to just check on the performance, taking into account all of the higher order interactions that the synthesis equation does not directly calculate. So in addition, you can also look at it in the 3D viewer that you have seen before. We can move and rotate the structure, and you can also look at the surface current flow. Now what is interesting here is I'm showing the surface current flow in the stop band. The lower stop band, you can see that there's no current flowing through here. And if I now scroll through, this is the current flow in the pass band of the filter. And if I scroll up the current to the upper stop band, again, the current does not flow. So this is a very good way to visualize what is happening in an electromagnetic planar structure by looking at the surface current flow as a troubleshooting tool or as a diagnostic tool. So that if you do need to change your layout, you change it and simulate it before you send it off to manufacturing. But let's say everything is well and good and you want to make this into a real prototype. Let me take you to another station to watch this exact filter being manufactured and being tested in the same day. In fact, in the next hour, you can get the physical filter in your hand ready for testing. So let's go over there and take a look. Hi, we're here in the station where you have seen how it was designed in Genesys. Now what we have done is to take that same filter layout, bring it across to the T-Tech IsoPro software, where it drives a machine. It's called a quick circuit machine that directly cuts the filter onto the PCB board. So why don't you come over here and look at the PCB board. And you can see it's an exact representation of what we have designed in Genesys. And here's the measurement. It's actually connected to the economy network analyzer from Agilent. You can look at the pass band. This is the return loss, and it matches very well. If you do the exact comparison, it matches very well with the electromagnetic simulation. So why don't you come over and look at the real filter as it is being measured. So what you saw there was a machine that only fabricated the PCB board or the RF board. But sometimes for power modules like this, where the PCB board is mounted directly on a piece of metal, then what you would like to do is the ability to not only make the circuit on a PCB, but also to mill the metal structure around it. And this T-Tech machine also allows you to do that because it has an automatic tool changer, changing to the precision tool to make the PCB structure, and then to more robust tool for actual milling of the metal housing. So that's another capability you have, and it's the fastest prototyping that you can do in the industry. Design in the morning and test in the afternoon.